There is a big difference between the way how these two observables work if we have more than one subscriber. Observables have landed in Chrome version 135 natively, and observables are designed to help you to manage events. The funny thing is, there has also been a library called RxJS for many years, which also provided observables, and now it is interesting to see what things RxJS and native observables have in common and where they differentiate themselves. This video is made for two types of developers. So if you have never heard about observables before, then you're on the right spot, please stay. And if you're a seasoned developer who has been using RxJS for many years, and you're now curious what is going to change, what the future of RxJS will look like, especially since we have now observables natively in the browser, then you're also in the right spot. This video comes with a basic and an advanced part, and in every unit chapter I am going to demonstrate you a certain feature. I will first of all start to explain how it works with RxJS, because this is the one that we had already for a very long time, and then I will show you the same example again, but just with native observables. So welcome to this video. My name is Rainer Hanekamp. I'm consultant and trainer at Angular Architects. I'm also a member of the NGRX team, so I'm very active in the open source community. That's it from my side. Let's start. So we are going to start very simple. You see here on the left, I have an HTML page which has an input field, a click me button, and I have here a main.js. We are importing first the native TypeScript file, where I will include all my native observable code, and then I also have my RxJS file where I'm using the observable coming from RxJS. Now we'll first start with RxJS to see how it has been working in the past. And you see here I'm selecting the input and the button by using the normal DOM elements, the normal DOM functions. If I want to say now, I want to kind of listen to the click event of that button, then the way how it works in RxJS, that I say here from event, I'm providing the DOM element, and then I'm providing the event that I want to listen for, like click. And this means now that I'm getting here a stream whenever this event happens, and value, in this case the event value is fired, and I can subscribe to that event, to that observable. So this is already an observable what we have here. So if I say here subscribe, then I'm providing a callback function, and then I can say console log. As I said, it's going to be very simple, console log event. At the moment you might say, okay, I don't really see the benefit of observables. That will come. It's just the basic stuff. That also means if I now go here and I click on the button multiple times, then we see that in the console the pointer event shows up. This was now RxJS, which means it was an additional third-party library we had to install. And if I now go to my main.js and I'm going to only use the native version, then we will see that now the observables are much more integrated, because now the browser really supports them naturally, natively. In the past, when you wanted to listen for an event, then you always said add event listener, then you had here the click and something else, so it's more like the button. And then you could provide here your callback function. And now to all those objects which are providing this add event listener method, there is now another method available which is called when. And this when wants to have from me the name of the event. So I say here it's going to be the click event, and this returns me also an observable, now a native observable. And I can subscribe to it exactly in the same way as I've done with RxJS. I just say here subscribe. I'm getting my event, and I say console log event. So I save it, then I click again on this button, and we see the pointer event also then shows up. So what's now the benefit of it? Well, since it's a stream of events, we can now manipulate these events. We can change something in their value, we can filter them, we can change something in their timing, but there is also a possibility to merge multiple streams together. That's the advantage of observables. Now, if we now go back to RxJS and we say we want to now try out those kind of so-called pipe operators, and let's just say we have here this input field, and what I want to do is that when I type something in, I don't want that the value does immediately emit or immediately is passed on to the subscription. What I want to have instead is that the input is only passed on if it has more than 2 characters. So in this case, we have to change then, of course, here also from button to input. The event we are listening for is an input event. And then we have this so-called pipe method. And with this pipe method, we cannot say we want to filter. We want to filter the value. So I provide you just a filter function. The filter function comes from RxJS. And the way how this works is that the pipe is designed to allow multiple filter functions. So I can chain them all together. Now let me quickly import it. I also need to provide here the event type. So I need to say that this is an input event. And as we will then see, the filter function will then also get the event, obviously. I can then say the event target, that one's going to be an input element, hopefully. I want to access the value, and I want to say I only want to pass it on if the value has a length which is larger than 2. That also means that first of all, maybe we can try it out. So I type here 1, 2, and then comes the third character, and then we see now the values are also being passed through. Now with this filter function, I can also combine it with others, as I said before. For example, I could say I don't want to use I don't want to have in my filter always this event target, fetch out the value. I want to do this before. I want to do this in a separate pipe function. And this is something I can do. So I can put the filter here, and then I can say I have a map function. Yeah, so with the map function, we again getting here the event. In the end, I'm doing the same thing, which I'm doing here with the filter. I just say here, this is a map. And instead of doing here some kind of comparison, I say, look, I'm only passing on the value to the next filter operator. And we see already that also the filter operator now says, oh, this is not an event anymore. It's now a string because the map has already done this pre-work for me. So the filter now has it a little bit easier because that one can say, okay, there's a value, and when the length is larger than 2, then I'm fine. I can then also say I want to have certain debug functionalities in it. I want to, first of all, allow that the subscriber only gets the filtered values, but I want to see all the values that come through. For this, there is something which we use very often, which is the tab function. And then I can say here console log, like this, which means whenever a value is emitted, it's also printed out. Yeah, so I can do it all, tick here, type something in. Of course, we cannot differentiate anymore if it's now coming from the subscription, if it's now coming from the tab, but that's why we can say here also, for example, debug. If I now type something in, 1, 2, we see that this is here coming from console debug. Now we don't see it. We don't really see it. So let's just say here, this is debug value, like this. Once again, 1, debug object input event, 2, and then I say 3, and then you see here the subscription shows it. So what else can we do, or what else is important before we move over to the native observables? the subscription is necessary. That is also something which you absolutely have to remember. When you have an observable, it doesn't do anything unless somebody subscribes to it. And here the tab operator can help us. Because if I would remove here the subscription, and the operators, as you see, they are all still intact, but I cannot type in whatever I want, nothing happens, because the subscription has not activated that observable. That is also very important. So how does this now work with the native observables? Let me go back. So we have here native, and as we have seen before, I need to say here in this case that's an input. We are also listening for an input event. I can of course also provide here the type. So I say it's now here, it's the input event. And then now it starts to become interesting. There is no pipe method. What we have instead is that these functions, which we have seen before in RxJS, are now methods of the observable type. So that means I can say here map, that's a method, and actually I can copy whatever I've done here. So I can put it like this. And the map is then returning me another observable where again, as you can imagine, can then say here filter. So I have here my value, and then I say I'm only letting it pass, letting it through if the value length is larger than 2. We can also give it a try. So if I now type something in, 1, 2, and I say 3, we see the same behavior that we had before. Why is there a difference? Interestingly, RxJS and its earlier versions worked exactly like this. So they also had all these pipe functions as methods of the observable. But there is a problem. RxJS gained more and more pipe operators over time. And then you can of course imagine that you then have a class with a lot of methods. The main problem though was the tree shakeability. Because when the TypeScript code, JavaScript code, when it goes through the compilation and through the optimization, then we try to remove those JavaScript parts which we don't need anymore. But we can't do this that simply with classes. I mean, we are not doing it, it's done by the bundler. But when the bundler sees a class with 100 methods, then the bundler can't say, okay, I'm now only using parts of that class. The bundler needs to include all of them. Whereas when it is like this in RxJS, where we have just simple functions, then it's very easy to add more functions to it, because then only those functions end up in the final bundle, which are really used. So that's the benefit of it. With native observables, we don't have this requirement for tree shakeability, because there is nothing in the bundle size. It's supported directly by the browser. We will see how it goes in the future when probably more pipe operators or methods are added to the native observable. If they think about introducing a pipe method, because one also has to say at the moment, I can't provide my customized, I can't create my own pipe methods. That's not possible. And we also know that some very important ones are, for example, missing. So one of the most common used ones, especially with this use case that we have here when we type something in, is a debounce time. So I could, for example, say I only want to, let me quickly show you the way how it works. So I could say here debounce time, let's say 500, which means when this event happens, then it does not pass on the event or the event immediately to the tab operator, but it says, I'm waiting now for half a second, and if within this period of time no further event is emitted, then I'm passing on what I currently have. If in the meantime, if within this 500 milliseconds I'm getting another value, I'm starting to wait again for another half a second. And this is sometimes quite important. And this is one method that the native observable, for example, does not have. There is no debounce time. So there are a few things that we have to be aware when it comes to the subscription. The first thing is that we need to know about the 3 channels. And the second one is the way how we have to deal with errors. Let's start with the channels. There are 3 channels available in a subscription. The default, the standard one, is called the next channel, which is the one where we're getting the events. And if we just have a callback function as it is here in line number 12, then this is exactly where the next channel is activated. If I want, I can also be more explicit. I can provide here the other notation, the other signature, where I'm providing an object literal, and then the property names contain the names of the channels. And in this case, I am assigning the next channel the callback for console log the event. The other 2 channels are called complete and error. So if I want, I can then also say here, I also want to listen to the complete channel. If that happens, then I want to say completed. And I also want to listen to the error channel. In this case, there is also an error available if I want to. So I say here console log error, something like this. If we are providing an object literal, then we can also pick one of the channels. We don't need to provide all 3 of them. I could, for example, say I'm only interested in the complete, but not in the next. But usually the next is always there. So does this work in this case? No, because we don't have here access to the inner observable. We haven't written it to the original observable. It does not kind of complete itself. But there are some functions which can enforce a completion. We can enforce a completion after the first element. We can also say, for example, after some time. We can also provide other observables. But we can also, for example, say take. And I say I'm only taking 2 values, and once they have been emitted, then I want to complete. Which means if I say here 1, 2, then these values, as you see, they haven't been passed on to the take function because they have been filtered out. But now we have the 3, then we have the 4, and then it is actually over. So we should now see the completed. 1, 2, 3, 4. Now we have here the completed. So that's the take 2 and the completed. If we want, we can also throw an error. So I can also say, what if I have here another tab function. Let's remove that one. And it gets a value. And I say if the value is RxJS, then I want to throw an error. So I say here invalid input. And that means now I can type in whatever I want. But as soon as I say RxJS, it says here error, invalid input. So we see here also the error object that we have received. The question now is obviously how can we deal with it? You have to be aware when an observable completes, first of all, it's over. So even if I would start to type some further values into the input field, this observable will not fire anymore because it has been completed. That is important to remember. The same is also true for an error. If we have an error, the observable is also done. So even if we would then say, okay, we have now a catch error or something, the observable, it's over. It will not emit any value anymore. And that might be a little bit misleading if we take a look at the function that we can use here, because it's called catch error. It kind of looks like it's catching that error and then everything works normally, but no, it doesn't. What catch error really does, it says, I will, if you have an error, I will listen to the error channel. And if you have an error, then you need to provide me, you need to give me another observable, an alternative observable that I will use instead of the original, because the original is gone. That's it, it does not exist anymore. That's why I have to say here something like an auth. Auth is a function in RxJS which allows me to create new observables. And I say here, okay, if there is an error, then I just want to return a dash, and that's it. In this case, I don't even need the event or the error, because I say I don't care, just return the dash. Which means, if I say now RxJS, we get the dash, it is completed, yeah, nice, but I can now again type in whatever I want, nothing happens anymore. Yeah, so the catch error is really replacing the original observable with something else. And if I don't catch anything, and I'm typing in RxJS, and I'm continuing to type something else, also nothing happens because the observable is gone. There is one way on how we can fix it, and that's the retry function. But careful, retry function, that one is really dangerous, but in this case it works. What the retry function is doing, it, in case of an error, is resubscribing to the original one. So again, it doesn't change the fact that the original, the first observable, kind of has been destroyed. It just creates a second one by resubscribing. Which means, if I'm now typing in RxJS, we see that we are only getting here RxJ, but nothing else. We also don't see here an error message. We also don't get a completed, because a resubscription has happened. Which means if I now continue to write something, then it continues. I said before that this retry is a little bit dangerous. Not in this case though. If you remember, I said in the very beginning, when you subscribe to something, you're activating the observable. And there are certain observables which, when they are activating, are starting to do something. For example, an HTTP request. Now it could happen if you're applying a retry to an observable which internally triggers a request, that this retry triggers another request, which again might fail. And then it retries again and again and again. And then what you can end up with is with an observable which continuously is doing some requests to the backend, which is absolutely what you don't want to have. So really be careful when you use the retry. You can of course also provide here a limit. I say I only want to retry 5 times, but you can also provide here certain logic. You could, for example, say you want to pause after the first failure for 5 seconds. Then you want to retry it again. If it doesn't work, then we wait for, I don't know, half a minute, then another minute, and then we say, okay, now it's over if there is still an error. That is also possible. Another thing when it comes to error handling is that you might say, well, actually, I don't really care if the observable ends because it has been completed or it ends because there was an error. I just want to do something at the very end. And for that, we have the function which is called finalize. So with finalize, we can say, I don't care what happened. I just want to say at the end, we are done. Something like this. So if I now say here RxJS, we say we are done, but we also see here the error channel has fired. And please remember, the we are done comes after the error channel, after the error callback. And if I would have a take 2, when I would type in observables, then we see it also stops after the first 2 values with the completed, and the we are done also comes at the end. So finalize, retry, and catch error are those functions in RxJS which we very often use when it comes to reacting to errors or when the observable ends. Now, how does this look with the native observables? The rules are the same. So if there is an error or if it completes, it's over. Unfortunately, we don't have a retry. But we have the catch and we also have the finalize. It isn't called finalize, but we have something with the same behavior. Let's take a look at it. So let me quickly go to main. Let's say we are going to reactivate the native part. And in the end, I can now also just copy the things. So I can go to my subscribe because the subscribe function in the native observable has the same signature. It also provides an object literal with these 3 channels. It's exactly the same. And we then, for example, also have here the take 2. So in this case, if I say take 2 and I type in RxJS, we see the same result. On the other side, if I say I want to throw an error, then I would require a tab, which we don't have. Instead, the tab is called here inspect. So I say here again, we have here a value and I say, okay, if the value is RxJS, then I throw a new error, invalid input. Yep. See the same thing again. Catch error is also available. It's not called catch error, it's just catch. We get access here to the error if we want. In my case, I don't need it because I'm doing the same thing that I've done before. I'm just returning a new observable as a dash. And again, we are replacing the original observable with something else, which is completing, but we don't have access to the original observable anymore. Off used to be a function of RxJS. With native observables, we have another one where we say observable from. And that one expects an array where I say, okay, here you're returning the dash, and it works in exactly the same way. So if I say here RxJS, we say it's replacing it with a dash, and then it's completing. And in this case, we never know that actually the reason why it was completing was an error. Now, if we want to use the finalize, it's the same thing again. It's called finally, and there we say we are done, like this. Let's try it out for the complete. So I say here RxJS, completed. And if I remove or if I don't, throw the error, like this. And probably also need to come up here with the take 2, because otherwise it's not going to work. We see that now we also have here the completed. Good. In case you didn't see it, there is one difference between the finally and the finalize. The finally always runs before the complete or the error channel callbacks are executed. So this we are done comes before the completed, whereas in RxJS it was always at the end. Might not be that much of a useful information in most cases, but it's good to know. So what else do we need to know about the subscription? There is also a different way on how we can unsubscribe. And in RxJS, that's very straightforward. So if we go back to RxJS, and the way how it works is that the subscribe method is always returning you a type of subscription, as you see here. So I can say here, const subscription equals from event. Let's remove all these functions there. Let's only do the filtering and nothing else. And now I can, for example, say, if I want to click on the button, then I want to do an unsubscribe. Yeah, so with the unsubscription works like this. I just go to my subscription and I say unsubscribe. That means now I am, as the subscriber, I'm just closing it from my side. It's a little bit different what we had before with the pipe operators, because the pipe operators with take two or something else, they always return us an observable. It's not a subscription yet because no one has activated it yet via subscription. So it's not the same that we have here, where we are here already running observable and we are saying, okay, now I'm not interested anymore. It's a bit of a difference. The way how we can do it, we have here our button. So again, if I say I want to do everything with RxJS or with observables, then I can again use here my from event against the button. I have my subscribe, and then I say, okay, once this is done, once the click has happened, I want to unsubscribe. So I can also add here a console log if I want to, where I say unsubscribing ... and then we print it out, which means I cannot type in as much as I want. It doesn't really matter. But as soon as I say here, click me, then we're getting the unsubscribe. And if I continue to type something in, we see nothing happens anymore. Careful. There is no complete and there is also no error, because this usually comes from the observable. The observable said, no, from my side, nothing has completed. I would still have the values, but if you don't want it, don't expect from me that I'm firing now via the complete channel anything. But again, if we would not say, okay, but I want to know this in a way that something has happened, that then the unsubscription has happened, then you can always use, of course, the finalize from before. So again, we could then say here, we are done, and we are providing then here the log. And if we're now doing the same thing as before, typing something in, then I click here on the button, then it says unsubscribing, and then we also get here this we are done. So this finalize, as you see it here, that works in both directions. It gets the complete and the error from the observable, but also from the other side coming, the unsubscription is also passed on to the finalize, and then we can also react with it. With native observables now, it doesn't change that much. At least the rules don't change that much. The way how the unsubscription works is completely different though. And again, one of the reasons is that with RxJS we have a third-party library, but with the native observables we are directly in the browser, which means we can use existing features which already do something very similar. And for that we have the abort controller. So let me go back to the native approach, to the native observables. Let's do the same thing here again. So I say I don't need the finally. Let's probably remove the inspect, and the finally let's just comment it out. And if I now want to see what the subscribe here returns, then I could say, do you return me a subscription? No, that's a void. There is no subscription. There is nothing returned. Instead, we can now come up with an abort controller. So I see here abort controller. That's a new abort controller. You might have seen that abort controller already in fetch methods. There it's very common to use it. It's something which also the browser provides natively. And when we are doing the subscription, we can provide the abort controller as the second parameter. Actually not the abort controller, but the abort signal. So I say here, abort controller, give me the signal. And now, when I want to do an unsubscription, again I need to have my event listener. So I also say here button, not from event, but with the when. So click, subscribe, and then I just say, okay, look, we have our abort controller. We want to abort the whole thing. And as we have done it before in RxJS, I'm also going to use here a console log where I'm saying I'm now starting the unsubscription. Which means I can now type in as much as I want. If I click on the button, we see unsubscribing, but again, complete and error did not fire. F. I'm going to activate now my finally again. And I'm doing the same thing. Clicking here on click me. Then it says unsubscribing, and we also have here this we are done. So it's the same rules, but still a little bit different because native is using the abort controller and RxJS is using the subscription type with the unsubscribe method. So one last thing before we actually take a look at the way how we can write our own observables, and that's the integration into asynchronous tasks as it is natively. We know that we have the promise type, which is representing an asynchronous task, and in RxJS there are possibilities on how we can map one observable to a promise. There is a challenge though. The promise has the requirement that it always needs to return a value, whereas with observable that is not necessary. So we could theoretically have an observable which never emits or which immediately completes. That is possible with observables, but not with promises. And the obvious thing, the observable can emit multiple values, whereas the promise only gets one. So in RxJS, we have two functions available which allow us to map an observable into a promise. And they are called first value from and last value from. And I think the name says everything already, says it all. Let's take a quick look. So we have here main. We are again activating RxJS. And I don't need to subscribe because when I do a mapping to a promise, then the subscription happens internally. So I can remove the part here, and instead I just say here first value from. And it's of course not a subscription anymore. This here is a promise of a string. Yeah, so it takes the last value and will then in this case wait for the first element, and then it will kind of unsubscribe itself automatically. So we also don't have to care here about the unsubscription. This is all done by the first value from internally. This also means that I now can say promise. Then I'm getting here for obvious reasons also the value. So I can say here console log value log, something like this. And if I now type in more than 2 letters, 1, 2, 3, then we see here finalize is running, but then also comes here the promise then, which says this is your value. Let's quickly remove the finalize. Let's also switch to the other one. Let's say here we have a last value from, and now it starts to become interesting because now we do have an observable which does not complete, which means I'm not getting here an error, but I can type in as much as I want. This promise will never resolve itself. So you can wait here for a very long time and nothing will happen. So what we could do here is that we can apply our pipe operators, our functions. In this case, I could say take 2. We know this already from before, which means if I say here 1, 2, and then 3, 4, the take 2 was activated, and then the promise is then also resolved with the value. So always be careful in RxJS. If you use a last value from, you have to be aware, you have to be sure that this is going to be applied to an observable which completes. If not, then you saw what happens. First value from is always the safer one. How does it work with native observables? With native observables, again, it's a little bit different. Let's do the same thing that we had here before. Because native observables has it built in. So again, it's not like you have to apply a new function, which can also be tree shaken. With native observables, we can do it via methods. So if I want to do the same thing, which I did before with my first value from, then everything I need to do is that I just say here first. So there are some methods which are already returning you a promise. which means if I say here promise equals, yeah, and I take a look, then it says, yeah, that is indeed a promise of a type string. And if there is a last, if there is a first, then there is obviously also a last. Yes, that one is also there. And there is actually a complete list of different methods which are returning you a promise. And then there is another list like the map, like the filter, which are returning you an observable. Yeah, so that's the way, very simple, very well integrated, how it is with native observables. So let's now take a look on the way how we can write our own observables. Because until now we have only used observables coming from the system, like coming directly from the browser where we're just listening to events, but we can also write our own ones. And again, we will start with RxJS. So, the way how we can do it, let's just say we want to have an observable which is emitting numbers. Then we usually, this is the way how we have done it for many years, when we have an observable, we append a $sign to the variable name. And we are instantiating the observable like any other class. So I say here new observable, and this observable wants to have from me now a function where it provides access to the subscriber. And the subscriber allows me now, or the subscriber object here allows me now to talk to my subscriber. So if I say here subscriber, what do you have? Then it says, well, there are these three channels, which we already know. The next, the error, and the complete. And this is the way how I can communicate. So if I say I want to emit here a number 1, then I just say next one. It also means this numbers is now the same type. It's now the same, it's now another observable as it was before with from event. And I can also subscribe to it. So I can say, yes, I want to print out the value. And you see, if it executes, it says here, yes, number 1 has been emitted. Careful now. Quite a lot of us who are using RxJS always think with observables emitting asynchronous value, which in most cases is probably true. But an observable does not define anything in terms of asynchronous tasks or synchronous tasks, or asynchronicity or synchronous. It always says, look, especially with RxJS, there's a very simple rule. I, as an observable, I wait that somebody activates me. And in order to activate me, somebody needs to call subscribe. Now what happens with subscribe is it's always the same. Subscribe is triggering this function here, this callback function. So that means if I would say here console log, starting observable, like this. We see it starts the observable, the next immediately runs. And if I would then say here finished log, then the finished comes at the end. So the starting observable comes first, then comes the number 1, as you see here, and then comes the finished. And there is no asynchronous task right here, because there is none. The observable itself on its own does not trigger any asynchronous task. It just says, if you call subscribe, I'm executing this function synchronously. That's guaranteed. Yeah, and then if there is no asynchronous task in it, there is no asynchronous task. Full stop. What does this now mean? If we want to say, for example, but I want to execute an asynchronous function, or I want that the observable emits a value asynchronously, well, then you have to do it. So it's your own responsibility. You can anytime start here a timeout, an asynchronous task inside of your observable, and you can say, okay, then it's subscriber next to, like this, and I'm doing it after 1 second. Then you see here on the left side, the observable starts, the one is immediately emitted, synchronously emitted, and then at the end comes number 2, asynchronously after 1 second. So very simple actually. And again, I said this already before, but just for clarity, if I'm not subscribing and I rerun it, then we are only getting the finished, and even the observable does not start. So we don't even see here the starting observable because nothing happens. The observable is lazy. And also remember, just by looking at an observable, you cannot tell if the observable emits synchronously, asynchronously, or mixed, because this is also possible. If I would say here subscriber next 1, 2, and then we have here a number 3, then what do you think what will happen now? The 1 we know will immediately be emitted. Then we have a timeout, which means number 2 comes after a second. But what's with the 3? Now, the 3 is also here synchronously, which means we will get starting observable 1, not 2, but 3, then comes finished, and then after 1 second comes 2. Yeah, of course, I also need to subscribe. Yeah, so 1, 3, finished, and then comes the 2. And this is crucial because you really have to understand when you're working with observable, when you're creating your own observables, the logic, the way how it works. It is really simple. It's just like the subscribe is triggering this function here internally. There is no magic with asynchronous or synchronous task. It really depends on the way how you do it. Now let's take a look at the native observable. How does that one work? Actually, let me quickly remove the 3 here because this was just for demonstration purposes. Actually, I can take it, I can copy it. I'm activating the native. I'm going back here. I'm pasting it in. I can leave the code as it is. It has, at least for this scenario here, the exact same behavior. Yep. So we have here again, starting observable 1, finished, and then comes the 2. If I'm not subscribing to the native observable, then also nothing happens. Exactly the same thing. But not really. Because there is a big difference between the way how these two observables work. And we see the difference if we have more than one subscriber. Let's switch back to the RxJS version. And let's just say I have another one. So 2 subscriptions. We are getting here the value. I'm saying here I'm sub 1 value. And then I'm saying here I'm subscription number 2 and I also want to see the value. Now what will happen? As I explained it before, we have with subscribe a re-execution of that function. If no subscription happens, this function is not executed. If 1 subscription happens, the function is executed. If 2 subscription happens, this function is executed 2 times. Which means we will see starting observable 1. We will also immediately see that here the subscription 1 gets the value. And then the second subscription kicks in, gets also starting observable. It also gets the number 1. Then we get the finished. And then because there is a delay of subscriber next to, after 1 second, both sub 1 and sub 2 will get the value number 2. Let's try it out. Yeah, so here we have it. Starting observable, sub 1 gets the value, then it's finished for some reason, and then sub 1 and sub 2 also gets the number 2. Now this is a little bit interesting. Why is that the case? Let me quickly think. We are here still in RxJS land. Starting observable, sub 1 finished. I didn't import it. Good. So here again, starting observable sub11, starting observable sub21. Then we are getting the finished, meaning the synchronous execution has ended. And then after 1 second, sub1 and sub2 get their value number 2. So we see that the observable has a point-to-point communication with its subscriptions, with its subscribers. And that's not the case with the native observable. And unfortunately, you have already seen it before, the behavior with the native one, because I've missed to import the RxJS observable, which means the behavior which we have seen before was actually coming already from the native ones. And that's very strange. Again, let me copy the whole thing again and let's go through it step by step. So this is main. It was a coincidence that this happened, but I decided to include it in the video because I think it's quite fitting. Good. So we see it here again. We have here not the observable from RxJS. IntelliJ wants to play a trick on me. Good. So here we have it again. Starting observable. We only see it once. Then we have a sub11, and then we have sub12, and then we have sub22, which means that the second subscription only gets the value 2, but not the value number 1. The native observable behaves like the RxJS observable together with the share operator. So it has a multicasting built in natively. What do I mean by this? First, the observable, as we have seen before, the native observable requires a subscription. That is necessary. The subscription starts this function. It emits, in this case, synchronously. But then the observable remembers that it has been activated in that sense, which means if the second subscription, that one comes along, the observable says, hey, I'm already active. You will be now my second subscriber. And if I'm going to emit a second value, then I will notify you. But you're not getting the former values like the one, because those ones have already been emitted. And this is exactly what we see here. Subscription number 2 only gets the second value. Which means if I would then say here, okay, we have then here number 3 is then emitted after 1.5 seconds, then the subscribe to would also get the number 3. Yeah, because it came right in time. It did the subscription before these 2 values have been emitted. I said before, it's like the share operator in RxJS. Let's verify if that is really the case. So again, going back to RxJS. And if I would say now, here, I also want to here apply pipe share, like this. Obviously, the share operator does not exist with native observables. So if I do it here, then we see the same thing again, like starting observable, sub1 gets only the first value, then it's finished, and then the number 2, which is emitted asynchronously, is then passed on to subscription 1 and 2. Okay? For those of you who are already using RxJS, you probably are not using the share operator. You are very likely, I guess so, are using a share replay with a ref count 0, a ref count true. That is a different behavior. It's not like the share, because what the ref count true is doing, among other things, but the important thing for this example here is that the share replay is using a cache internally. It's using a replay subject. It's not so important, but it caches the values which it has, which means if somebody comes too late, it will replay all the events, and that means that now also the second subscriber gets the number 1 as well. But we still have just one execution, we have just one activation, we have just one time that we are seeing in the console starting observable. Yeah, so starting observable, sub1 gets the 1, sub2 then also gets the 1, then it's kind of finished, and then the both are getting also the values. That's a behavior we can't have in native observables because the share replay is something, again, which we only get with RxJS. Good. That might have been quite a lot, but I think it is crucial that you really can understand exactly the way how the values or why the values are emitted as they are, and you're also able to predict it if you can see at least the implementation. I can promise you it might not be that easy in the beginning, but once you have it, RxJS and also the native observables won't be a problem anymore. It's then very simple and very easy. I personally think that this implicit shared behavior of the native observables are better than the one of RxJS. Especially if we have observables which are dealing with HTTP requests, we see that there is a real benefit with the native behavior. Let me show you what I mean. Let's just say this observable which we have here, we want to fetch data from the backend. We want to fetch an array of existing flights. The way how we can do it is that first of all we probably want to change the variable name. We want to say that is now flights, like this, and then we are using here a fetch inside of the observable. So we have here a particular URL. Let me quickly find it. Yeah, there it is. So we have here a fetch. The fetch returns an observable, which again requires us to wait for the full response, which again is an observable. And then at the very end, we are getting here the flights. Once I have the flights, I'm going to emit them. So I say then here subscriber next. And here you have your flights. Of course, I also need to do a few changes here. I need to say, well, this observable here, that is actually, let's just say that's an array with an object literal. And I probably also want to change a few things here. So that's going to be flights. And then the flights, I also want to access the length because I don't want to see all the different object literals in my array. We see that we are getting here, both subscription do get their values, but the problem now is with RxJS observables, every subscription is triggering this request, which means if I go to the network, then I also see that I have here 2 flight requests. And this is something which, to be honest, I don't like. Because I say, what's the use of it? I have already the data, why not just providing it? Why not just do multicasting in that case? And this is what native observables are doing natively. So if I would now kind of take this code, go to native and say here I want to paste it. Probably also need to remove the observable here, that I'm using the native ones. Then we see again, let me also switch over. Then I see here 1 flight request, but both subscriptions also get their values. So in this case, we need to say, okay, the native observables fit much better that use case. I'm careful about one thing though. There is a certain behavior with share, which again is better in share replay. Unfortunately, we don't have a share replay. When the observable completes and another subscription comes along, then that one is reopening the observable in that case. Very simply put, there is a property with share operators which is set reset on complete, which is set to true. And to make it short, the problem in this case would be that we again end up having 2 requests if the second subscription happens too late. So what I would have is that I would say here, first of all, what have I done? Let me quickly go back. So once the flights have been emitted, I can then also say, okay, now it's done. You will not get any further data. There is just one response. And in this case, everything works fine. So we see here the network has just one request. That's good. But the problem is, if I now start with a set timeout here, and I say these flights, they are starting doing their work after, let's just say 1 second, then we see the second one also receives it, but unfortunately it comes with an additional request. That's the way it is. Again, this is this reset on complete behavior which the native observable has. If you use RxJS with share replay, you don't have it because the share on replay does not complete itself or reset itself if the internal observable completes. Maybe a minor thing, but it's also worth mentioning. We have now seen how we can create our own observable, how we can emit values, how we can complete our observable. I think it's obvious how we can throw an error. We just need to say subscriber error. It's the same thing. But there is one thing where, again, native and RxJS observables differentiate themselves, and that's in the way how the unsubscription works. If you remember, I as a subscriber, I can always say unsubscribe in RxJS, and if I'm a native observable, then I can use my abort controller. We are here again in RxJS land, and if we would now say we have here this request, and I want to allow that these flights could be unsubscribed, and if that happens, then I also want to kind of cancel this request if it's ongoing, then I need to do it in the following way. The RxJS observable can return you a function. And this function will be executed when the subscription unsubscribes. So I can say here, console log. From the perspective of the observable, it's not called unsubscription, it's called the tear down function, which is executed here. So I would say here tearing down. And then I need to cancel this fetch request, this ongoing fetch request. And the way how we do it is that we just use the abort controller. So I say here abort controller, the abort controller like this. The fetch has also a second parameter that looks very similar to what the native observer provides in its subscribe method. So put it like this. And probably if the abort controller fires, the promise will reject. So we also have to deal here with this. So I just see here catch void true. Just want to catch an error. And well, here we are in our tear down function. And if that's going to happen, then I need to go to my abort controller and I need to say abort. For obvious reasons, the abort controller needs to provide the signal. Yeah? Which means if I have in my subscription and I'm fast enough to say set timeout, yeah, then I say here subscription, unsubscribe. After, let's say 10 milliseconds, this should be fast enough. Then we should see something in the browser. Right, tearing down, it shows up. If we go to the network, we see here it says cancelled because we did the subscription in a time when this request was ongoing, when we were waiting for the response. Okay, so this is the way how it works in RxJS observables. And if we would now go over to the native ones, then that's a little bit more easier, especially here with the abort controller. So let's just say we have here a flights unsubscribe. As we know, native observables, we are canceling them, we are unsubscribing via an abort controller again. So this time the abort controller is outside of the observable. I say here in the subscription as the second parameter, here you have your signal. abort controller signal, like this. And then we are doing the same thing again. So I say here, do we have the abort controller already? Yeah. Well, there we are. And then I'm doing the same thing again, that I say I have a very short timeout where I just say abort controller, abort. And I'm doing this within 10 milliseconds. And the question is, what do we have to do now in the observable? And here, the native observable is, I would say, more explicit, more easier to understand, because we don't return a function which is the teardown function. We are much more explicit. We can go to our subscriber and we can say, look, I want to add a teardown function. So that means actually I can do here some stuff if I want to. So I can say here console log tearing down. I could now also create my own abort controller as I have done it before in the RxJS observable, but I don't have to do it because my subscriber also has already the abort signal from the abort controller. It's already built in. We just need to pass it on to the fetch function. So I can say here, hey, look, here you have your signal. I have it already for you. Just take it. Of course, I also need to then provide here a catch method that is necessary, that we don't get any strange error messages. But that's it. It's very simple. And we see here again, quick check. We are on native. We see here that in the network, this request got cancelled. In the console, everything looks fine. We also see here our tearing down function. Everything's perfect. So we have now finally reached the last part, which is about when we are dealing with nested observables. Let's say we have here our input field. And let's say if I have, as a user, if I start to type in some values, that for every input that I do, I want to have an additional request. So I want to have some kind of an autocomplete for my flights. In order to achieve this, I need to make here some arrangements. So first of all, I probably have to also do here a subscriber complete. I should have done this already before. And I need to make a function out of it. So I have here a function which is called find flights. I say you give me a string of from, and I am going to return you this observable. And I'm going to use the from here as a query string, like this. So we have now a function which returns an observable. We can remove that part here. And if you remember, we have here already the observable for the input field. So I'm going to reuse that one as well. So no last value from, it's not necessary. We just say here from event, and the take two can also go away. Now, if you are using already RxJS, you know probably what is going to come. And if you don't, then the way how you would probably approach this issue is you say, okay, you're getting here the value from the input field, and you want to map the value to an array of flights, which means you probably go with a map, because this is what it says. So we have here this from, and then I say find flights, and I'm going to use another from. Now the problem is, if we are looking at the resulting types, because I would say that's a flight array, that's a flight observable, then it's not. Because TypeScript now says, look, this is an observable which contains another observable, and that one contains the flights you want to have. That was not my idea. And there is now another function, and that one is called switch map. And the switch map is doing exactly what we were hoping for. If we're going now to flights, we see it's an observable, just one observable, which contains those flights. So the switch map is doing two things. The first one, it waits for this inner observable. So what find flights is returning is something we call the inner observable. It waits for it to emit its values, also to complete. Then it passes on that value to the subscriber or to the next pipe function. This is one thing. The second thing is, if it is waiting for a response and we're giving it another from value, then it is canceling the one which it is waiting for and is starting a new request. So it really cancels requests. And this is something we can see. So if I say here subscribe, console log, like this, and I'm going full screen in my browser, and I can start typing in some things, yeah? And we see nothing is happening, and the reason is because I did not switch over to RxJS. Now we are talking. Good. So I'm typing in something very quickly. I go to my network, and we see here that all these requests have been cancelled. For obvious reasons, if I would do the typing a little bit slower, yeah, then you see there is no cancellation necessary because the requests here are also very quick. This is switch map. This is the behavior of the switch map. Careful if you use switch map in cases where you are required that all the requests are processed by the backend, because there is a risk that this does not happen, as you have seen. Now in that case, please use something else. You can choose between a merge map and a concat map. The merge map in RxJS, if I say here merge map, let's quickly open it, and let's just say I'm on a slow network connection. Then you see here in the timeline that the merge map is doing a parallel processing, which is fast, but it also has its downsides, which is it doesn't keep the original order in place. So it could be that, let's say you have two requests, that the first request takes a little bit longer than the second one, which means in your subscription, you're getting the answer from the second one first, and from the first one you get that 1 second. If you say that's fine for me, I don't care about the order, then please go with the merge map, because you always have here the guarantee that all the requests are going to be processed. If you say, no, that's not what I want, I need to have the order still in the same way as it was originally, then you can use the concat map. So if I do this, and if I go back, let's say no throttling, 3G. And now you see, because I'm using the concat map, there is a sequential execution. It is taking longer, yes, but you have the guarantee that there is no mix-up in the order. So this is what you need to remember: switch map, concat map, merge map, when you're using RxJS together with nested observables. There is also an exhaust map, which we're not going to cover here, because we are now moving on to native observables. Can we do the same thing with native observables? So let's quickly switch over. Let's say we have here the same thing again. We have here the function find flights from string, return new observable, like this. I'm going to use here the from, and then I have here my complete, that is important. I have here my input, that's good. So, and you might not be surprised if I'm telling you console log. There's also a switch map. So you can say, okay, you know what? We can even shorten it. I can also say here, just find flights would have also been worked with RxJS. And then I say here, I have my subscription with console log. It's the same behavior, canceling of requests. So if I say here again, no throttling, I go to my console, I'm typing in something very quickly. Then we see here that some cancellation have happened. And then instead of the merge map, concat map, we have something else as the alternative when we say we don't want that requests are cancelled. And that's the flat map. So we see from the output, it's still the same. So the subscription here is still returning us the flights array. So it's also waiting for the inner observable. And if I now say very slow network, and I'm typing in very quickly, then I'll let you guess what this is. Yeah. We see sequential processing, which is the concat map. So flat map in native observables is the concat map, and the switch map is also the switch map in RxJS. Everything's there. So we have now reached the end. What would be the next steps? Well, I would say, first of all, the other browsers also need to make sure that they are integrating the observables as well. But the bigger question will be, how will RxJS respond? How will the next version of RxJS look like? Will it align, and how much can it actually align to the native observables? I'm quite positive about it because the native observables have been mainly designed by two people, and one of them was Ben Lesh, who's the maintainer, the co-maintainer of RxJS. So chances are very high that we will see an alignment in version 8. Once version 8 comes out, I plan to come up with a separate video. Maybe that one is going to replace this one here, but we will see. I don't have any dates or something else. What I would be interested, especially if you have already been using RxJS, would you be willing to switch to native observables, or would you say, no, there are some things missing and that's why I can't do it? And if you haven't used RxJS until now, do you see a need for these native observables? That would also be very interesting to hear. Other than that, as always, if you have any questions, any comments, then please just ask. And well, at the end, I have to want to say thanks for watching and see you in the next video. Goodbye.